When you read this line, it looks like the object is doing something. That's the illusion object-oriented syntax creates. It reads like English, but nothing in this line tells you where execution happens or how the object is involved. That's what we're going to trace. Not design, not meaning, execution. Because if you can't explain where the code runs and what data it touches, the syntax is lying to you. At runtime, this call is treated like a function call with an extra argument. The object does not execute code. The method executes code. The object reference is just passed in as data. That's it. This rewrite is not conceptual. It's mechanical. Everything that follows in object-oriented programming depends on this one idea. If you don't understand this transformation, methods stop feeling simple. When the method call executes, a stack frame is created. Parameters are bound. And this is assigned the object's address. That's all this ever is. A reference. Not context. Not magic. Just a pointer to memory. Every method call creates its own frame. When the method returns, that frame disappears. The object stays.
Inside the method, field access always goes through this, even when you don't write it. The runtime uses a reference in this to locate the correct memory. The method doesn't know or care what the object represents. It reads a value. It writes a value. If this points somewhere else, the same code mutates different state. This is where confusion usually starts. Same method, same code, different result. Why? Because this changed. The code didn't. Every method call binds this to the object reference used in the call. Track this, and behavior becomes predictable. Lose track of it, and everything feels random. Here, both variables point to the same object. When b.login runs, this points to the same memory as A. The method executes correctly. The confusion comes from assuming variable names imply identity. They don't. References do. This is one of the most common sources of bugs in object-oriented programming. This entire walkthrough reduces to 4 rules. A method call creates a stack frame. This is bound to the object reference. Fields are accessed through that reference. And state persists after the method returns. Nothing else is happening. If you can trace these steps, methods called stop being mysterious. If you can't, no amount of abstraction will help.